Hello everyone. Let me explain first of all what's the problem is here that we are dealing in the chapter magnetism and matter. The problem is like this. A bar magnet is cut into two pieces along its axial line. I'll stop here for a while and tell you what happens when you cut a bar magnet along axial line. Yeah, let's consider a bar magnet. Let this is its north pole, this is its south pole. The distance between the poles is being called as the length of the magnet. Each pole will have a strength called magnetic pole strength. Now, this has a magnetic moment M. Now it is cut along axial line. This is what do you mean by an axial line? Line passing through poles as well as the magnetic center is called axial line. So when you cut this into two pieces, it will become two pieces, each of pole strength M by 2 and another M by 2. These are the two pieces now. You might have noticed the length remains same. So what happens to new magnetic moment? M dash of each piece is pole strength has become half, but the length remained same. So magnetic moment of each piece, this is also M by 2 of length 2L. Each piece now is having a magnetic moment of M by 2. But now further he is saying, yeah, let's look at the problem. One piece is further changed into a shape of a half circle. Now look at this part. This is now converted, this one piece, any one piece, into a half moon of the circle like this. Now, as the distance between the poles has been changed, though the poles remains the same, like north and south, north and south, north and south, the distance between the poles got affected, and hence the magnetic moment of this piece is no longer m by 2. It gets changed. To what it changes, we need to find out. Then he is saying that two pieces are kept together. So what is the new magnetic moment is? So before going to that part, I need to handle this part. What is the new magnetic moment of this piece, right? So probably you have seen the previous videos in the playlist. We have discussed that when a magnet is changed into a arc, when a magnet is changed into an arc, new magnetic moment m dash is 2m sine theta by 2 by theta, where m is the original magnetic moment and theta is the arc angle that is being made at the arc. Now, being it is a semicircle, the value of theta is pi. M is not equal to m here. This is not m because this is already a half magnet having a magnetic moment of m by 2. So, for a half circled magnet, new magnetic moment m dash is 2 in the place of m by 2 because we have taken only half magnet. Sine theta by 2 is sine 90, that is sine pi by 2 is sine 90 by theta shall be expressed in radian pi. So what will be my answer? This 2 and this 2 will be cancelled. M sine 90 is 1 by pi, m by pi, or m by 22 by 7, or 7m by 22. Well, that's the magnetic moment of the one piece. Now let's go to the problem and see. He's saying like one bar magnet, half the piece of this 7m by 22 is in contact with the other piece of, so this piece is having 7m by 22, right? And this piece is having m by 2. They are in such a way that opposite poles are in contact like this. So each of this magnet has its moment's direction from south to north. That's the direction of the length of the bar magnet. So these two moments are in the same direction. So what's the resultant magnetic moment is m total is, I have to just add both of them because these two are the vectors with a zero direction between them, m by 2. So that could be the answer. I can leave there, or I can simplify. 22 is an LCM, 7m, and this will be 11m. So that will be 11 plus 7, 18m by 22, or I can write that as 9m by 11. That's how I can solve the problem, but it's all basically talking about the resultant magnetic moment and its direction.